Hello, everyone, and welcome to another episode in my climate debunking series. In this episode, we will be debunking climate change using the very important specific E capacity, the scientific property of specific E capacity. This is another of the ongoing scientific property that we will be looking at. There are many of them, and this is just one of many. Many more to come in the future. So sit back, relax, and enjoy. We will now define specific E capacity. Specific E capacity can be defined as the amount of heat in joule needed to raise the temperature of 1 kilogram of material by 1 kilogram or 1 degree Celsius, and is measured in joules per kilogram Kelvin. Every substance on Earth has a well-documented specific E capacity. Every substance. The higher the specific capacity of a substance, the less its temperature will change when exposed to a specific amount of heat, which also means that it is much better at absorbing and holding heat than any other substance with a lower specific heat capacity. Insulators will then have higher specific heat capacity than conductors, meaning that they will heat up and cool down much slower than conductors. Specific capacity is a measure of a substance's reactivity to temperature in regards to thermal energy. And most importantly, for the benefit of this presentation, for atmospheric gases, the higher the specific capacity, the greater effect it will have on the atmosphere as a greenhouse gas. This is one of the most important factor of specific capacity in regards to debunking this climate change myth or hoax. For atmospheric gas, the higher the specific capacity, the greater effect it will have on the atmosphere as a greenhouse gas. And as you can see to your left, the equation for specific capacity is E, which is the energy, is equal to mass times the specific capacity of the substance times the change in temperature. Here we'll have a visual perspective of what specific capacity is, and to your left you see a 3 bottles of different size of water, different volume of water. A specific can better be explained using these 3 bottles of water of different size. The bigger the bottle, the bigger the bottle represents the bigger specific E capacity of the substance. So a bigger bottle as compared to a smaller bottle will fill up slower, will overflow slower, and will empty slower. In example of the climate gases, the water in the bottle represents the amount of heat each molecule can hold. Here we'll be looking at a specific capacity substance comparison. And as you can see from the data listed, representative sample of all type of substance ranging from metallic, ionic, covalent substance, inorganic or organic, with increasing specific E capacities. From the diagram, you can also see that metals have a relatively the lowest specific E capacity. They heat up and cool down very quickly and are very good conductors. Inorganic materials such as glass and concrete tend to have medium specific heat capacity and tend to be good drivers of heat production in nature due to their abundance. Organic materials tend to have medium to high to the highest specific heat capacity and tend to heat up and cool down very slowly and are good insulators and excellent at moderation of heat. This quality is very important for the preservation of life against the ravages of heat or lack thereof. We will now be looking at substances with the highest specific heat capacity. And as you can see from the list, uh, hydrogen has the highest specific heat capacity of all known substances, followed secondly by helium, fresh water or water, sea, fresh or salt, and the human body or human brain, high up there in specific capacity. There's a reason for this. Nearly all the matter created in the sun is just two elements. 70.6% is hydrogen, while 27.4% is helium. Hydrogen is combined via nuclear fission to give helium, and a huge amount of energy that we enjoy or bask in from the sun. Secondly, the Earth's surface is 70% water, fresh and salt, the substance with the third highest specific heat capacity after hydrogen and helium, and which is what makes life on Earth possible by effectively moderating the thermal energy from the sun itself. This is no coincidence. Human body is also has a very high specific capacity in order to be effective in the moderation of thermal energy to sustain life. And as we all know, human bodies also are comprised of at least 7% water. This is also no coincidence. So the substance with the high specific capacity shows that how important these substances are in having these specific capacity. And these four substances is form the basis on life of life on Earth as we know it. We will now be looking at the specific capacity ranges for all Earth natural occurrence spheres. Earth has four spheres that interact with each other to make life possible on Earth, and they are listed as water, which is the hydrosphere, organic matter, which is the biosphere, the air or atmosphere, inorganic abiotic material, which is the lithosphere, such as rocks, building, car, metals. And as you can see, the listed specific capacity, water again has the highest specific capacity here, followed by the biosphere, then the atmosphere, and then finally the lithosphere. Just as note here, the third highest, water is the third highest from as mentioned before, the third highest specific capacity after hydrogen and helium, and organic material comprised of all inanimate or animate organic substance. And in regards to the air, which is the average of all atmospheric related to their concentration. So this gives you an idea of the ranges of the specific capacity in regards to the various spheres on Earth. We will be having a look at the high specific heat capacity of animate or living nature. Organic material, alive or inanimate, all have very high specific heat capacity. This is most important to animate or living tissue due to the necessity for temperature control to sustain life. This very high specific capacity affords living nature the ability to prevent swift heat buildup inside the body in the presence of excessive heat, and also swift removal from the body when the heat is in short supply. Both qualities important to the control of temperature and to the preservation of life itself. Living tissue also have a very high percentage of water that greatly enhance its overall specific heat capacity, as water, as we have seen, is the third highest specific capacity of all substance. In order to having a high specific capacity, living tissue also control heat buildup by eliciting the help of evaporation of water from the surfaces to remove any excessive heat buildup. This is called transpiration in plant and perspiration in animal. And as you can see from the photo on your right, there's a man and his dog camping or taking a walk in nature. And These two animals, real animals, have a high percentage of water, and as you can see, they're looking at the big lake, and the lake is an important part in the control of heat from the sun. The water absorbs a lot of the earth, the sun thermal energy, and we will be looking at in the future. We'll be looking at a slide that shows how important the water cycle is, and water is to the preservation of life on earth. Here is where the rubber meet the road, because in this slide we will be looking at the specific heat capacity of atmospheric components. We'll be doing a comparative analysis of the various atmospheric components in regards to specific capacity, and also in regards to atmospheric concentration, but two very important properties. As we have stated earlier, the greater the specific capacity of the atmospheric component, the greater it will be its greenhouse gas effect. That is very important to note. The greater the specific capacity, greater the greenhouse gas. As you can see from the table on the right, carbon dioxide has the lowest specific capacity of all the various atmospheric components that's listed. Therefore, carbon dioxide will not hold and absorb with less heat, but also but gives up the heat quicker to the other gas surrounding it. Example: nitrogen, oxygen, and water vapor, and also cool down much quicker. So carbon dioxide will not hold. It just doesn't. The figure doesn't show that carbon dioxide will hold on to any heat. Carbon dioxide is also has the lowest concentration in the atmosphere, and as a consequence of these two listed qualities, carbon dioxide gas is the least significant greenhouse gas in the atmosphere. It's obvious. Nitrogen and oxygen are very significant greenhouse gas by nature of their medium specific heat capacity and very high concentration in the atmosphere. Water vapor is also a very significant greenhouse gas by virtue of its very high specific heat capacity, irrespective of its relatively low atmospheric concentration compared to oxygen and nitrogen. It has a very high concentration when compared to carbon dioxide in the atmosphere. Water vapor and water has a very high concentration in the atmosphere as compared to carbon dioxide. Let's look at the logical conclusion. We can now answer the question as to how effective is carbon dioxide as a greenhouse gas. If it has a trace gas designation, also the lowest specific capacity of all the atmospheric components, I will go out on a limb to say that it is not a very effective nor significant greenhouse gas as compared to the others. In fact, I would say it is rather insignificant in this regard. There is nothing special about carbon dioxide thermally that can offset its trace gas designation that would make it a viable greenhouse gas. Nitrogen and oxygen, which constitute close to 99% of the air together, constitute a major force in the greenhouse or heat insulating gas that make life possible on Earth. Water and its vapor, by virtue of its unique high specific capacity, its abundance, and other scientific properties such as lighter than air as a gas, and its high latent heat capacity as it transforms between the various states, gas, solid, liquid, and gas, does make it the most important greenhouse gas. Water and its vapor, working in conjunction with nitrogen and oxygen, thus makes an effective team in the management of Earth thermal energy for the preservation of life. As for carbon dioxide, to play a role as a greenhouse gas, with its listed specific heat capacity, it would have to reach a minimum atmospheric concentration of at least half of that of oxygen, which would be about 10%. At 10% concentration, carbon dioxide would not be a traceable gas anymore and would now have some effect on the Earth's atmosphere. At this concentration, we would not even have to concern ourselves about global warming due to carbon dioxide, because carbon dioxide toxicity to life on Earth start at a mere 0.2% and is absolutely deadly to us at 5%. Nature aggressively removes carbon dioxide from the atmosphere and will never allow such concentration to be possible in the atmosphere. And finally, carbon dioxide level need to affect climate change, as the climate alarmists describe it, would have long killed all life on Earth before affecting the climate itself. So there you have it. This is the end of this presentation, in which I've used a specific heat capacity as a mean of debunking climate change. My next debunking video will be all about water. Water is a very important substance on Earth. Life on Earth is impossible without it. I will go into very detailed very detailed properties of water and how it controls heat, the distribution of the heat from the sun around the Earth, therefore making life possible on Earth. So this is the next video that will be following this one. Maybe by the end of the week or another week, I will drop that one. Please like, subscribe, and put your notification on so you can know when this video and new videos is dropped. There's quite a few more exciting video coming up to debunk this climate change, and as you can see, the topic to debunk climate change is almost endless and based on science itself, because science does not support climate change. So that's why I have so much material. So therefore, thank you for your time and patience, and I hope this video was educational for you, and that it will make you take the time to do your own research and to verify everything that I have listed in this presentation. I am not above anybody researching my material to verify for themselves. Please do so. You're encouraged. You're absolutely encouraged to do your own research. Thank you very much, and see you in the next debunking episode.